only the right questions. It's Quintessential Talks.
Wastewater treatment is a very important part of our society. It is very closely linked with our public health. Equally as important is wastewater monitoring. We need engineers to build systems that continuously monitor what is going on in our wastewater plants, so they know and we know that they are running efficiently. Wastewater plants in the city might be efficient and up to date. However, more rural areas either have outdated wastewater monitoring equipment or lack any wastewater monitoring at all. Tom Davies is an asset and sewerage manager. He is working on the implementation of a lower budget online monitoring system for a rural wastewater sewerage scheme. He has been implementing this scheme in a rural part of Australia called the Shire of Moora. So the Shire of Moora funded your research. Where exactly in Australia is this Shire of Moora?
Shire of Moora is about a bit under 200 kilometres northeast of Perth. It's considered rural just because that's the main activity, and it's a fairly low population density. Like the town site only has about 1,500 people. This project is interesting because when I did research, there was a lot of papers written on urban wastewater treatment plants and for built-up areas. And there's a lot of solutions, different types of solutions, and they're on a different regime, they're on a different budget and different sort of process. And our process is a little bit simpler and it's low budget. So we were looking at the correct solution that could be dropped on top of what we had. Then the thought occurred to me, well, this sort of concept could go anywhere because most of the world, or most of the rural, the non-cities, the non-urban areas would have something very similar.
When Tom was met with this challenge, he knew that he was going to have to up his skills because of how far the technology has come in terms of monitoring with sensors and the like. So Tom did some online courses through the Engineering Institute of Technology. Tom eventually progressed to the point where he had to compile his master thesis, of which his design and implementation of a rural wastewater sewerage scheme became part of his final thesis.
We basically, me and another bloke, had to sort out all these problems, and neither of us had experience specifically in wastewater. We were sort of, we were getting through everything and doing fairly well, and then we came across this little device called the PLC and alarms, and that looked a little bit trickier. Being local government, they're quite, I wouldn't say liberal, but they're quite generous with the training. So I requested a short course, and that was EIT, I think it's PLC's Professional Competency PLC course. And then from that, I really enjoyed that course because it was online. I was really happy with it. It was a lot of software that we downloaded, a lot of simulation software, and it really got my head around the whole concept. And I had a feeling I'd enjoy it, because of IT and maths background, and that basically led into the following course. The other thing that spurred the course on was the fact that the Shire was going to allocate quite a large budget for an external engineer to upgrade the automation system, the alarming system. And I sort of put my hand up and said, put me through the course and I'll sort out your system.
Yeah, so they had a SCADA system already before you arrived, but now you implemented a new SCADA system for the Shire of Moora. So what was the problem with the one they were working with?
The previous one was designed for their software, which they didn't provide with the handover. So I believe these units would have been from just the 90s, I reckon. And what we had to do, they basically were attached to a phone line, and they dialed through, like analog, they dialed through to a SciTech server in Geraldton, which is about 300 kilometres away, and that was for watercore. So we were without that central system. So I had to reprogram each of these dialers to ring us on our mobile. So we would, for example, we've got 7 pump stations, so if pump station 3 called us, we would just get a call from pump station 3, then we'd get that analog tone that meant something to the SciTech server but meant nothing to us. So we couldn't even tell what alarm was being triggered. We just knew that pump station 3 had a problem. So that was, there was lack of information. It was just a very clumsy system. And it's just an old system. And even the inputs, it was just at 3 or 4 digital inputs. So, we've gone with analog. So we've got a continuous monitoring of the levels and a continuous monitoring of pump currents. And I think that's much better. It's still low data, but it's much better than just finding out when something's gone badly wrong. You can actually monitor rather than just be alarmed.
Obviously, this one is now Internet of Things compliant, which is something that the previous system obviously didn't have, like you said. Being continuously online, what are the benefits there?
The continuous online means that what we can do is we can anticipate an event, an incident, and we can alarm it at an earlier stage, basically. And the other thing too is with your continuous online approach, you can see different patterns. So, for example, for pump current, different behaviour of the pump might mean different problems. So one particular set of the way that the current goes, if it jumps up high and stays high, it probably means that a rag's gone into the impeller. If it slowly degrades and goes up over time, probably that means the pump needs a service. It might be bearings or something like that. So having the trends and the patterns, you can we haven't done that to the full degree, but I hope to sort of derive some patterns out of that. And, you can marry everything up too with the water flows just to make sure that the pumps are performing as they were last month. And if they're not performing the same way, why? So, different type of patterns will be characteristic of different types of problems, and that saves money in diagnosing, maintenance and that sort of thing.
Yeah, because that can all be consolidated into some sort of like data representation where you can see, based on these kind of things that the data shows us, this is what could be wrong with an impeller or the system as a whole.
Yeah, and you can actually script this system that we've got. So you could put in algorithms to measure the deviation and that sort of thing. And essentially you could write a script, define each type of problem by its characteristics, the way that it affects the water level and the way that the pump current is affected. There's a lot of data that can be pulled out of just a couple of sensors, a minimal amount of sensors, and a knowledge of the system. You can get a lot of data out of it. So it's almost, rather than the big data problem that everybody's having, it's manipulating small data.
You've said in your report that you believe that this is the first of its kind for a rural and a regional environment. Would you be able to then create a system that can be implementable for other rural regions of Australia and potentially the world?
I think so. And, the wastewater and sewerage, it's been done by another professor, and I suppose it's an industry that's left alone. There has been concepts of affordable sewerage, and that's been laid out in third world countries, sort of like a blueprint, a general pattern that can be laid out for them. Something like these types of technology, once they've been maybe a bit more refined and better suited to each economic level, they can be basically as a layer whacked on top of these cheaper, or not cheaper, but low budget sewerage schemes. So, low budget sewerage scheme will have a low budget automation system, but it'll still be economically viable to have that.
In your opinion, the health and the well-being of a region hinges on a country's wastewater management?
Yeah, it does. Yeah, it makes a big impact on a small community. And, these lagoons aren't so far away from where people are living. The pump stations are right in the streets that the people live in. So they can't overflow. They can't stink. They have to be managed really well. Yeah, this sort of monitoring just reduces the probability of something happening. So it's a good step.
I think it's an honourable thing that you did in your master's thesis already, because, coming from an African perspective, we want something like that as well. We want people to study and train to implement these kind of things in the very rural areas, because they need help in terms of technology. And that technology is not even that expensive, especially since you've said it's probably just 10,000 Australian dollars. So we can just calculate that in our own currency, and then we can see where to implement it in terms of our own systems here.
I imagine your environment would be really quite, your rural environments would probably be quite similar to ours, and probably with budgeting and that sort of thing, it's probably all at these technologies would be the same thing. You'd use it over there, no doubt. But I think it's a contribution. The study was being able to do it was a contribution to the development of these types of technology. So, if a tiny improvement come out of it, that's great, and I'm sure other people will do, better and smarter and cheaper things.
Yeah. Well, Tom, it's a very interesting field that you are involved with, and I think obviously for public health reasons, it's a very important field that you're involved in. In terms of studying through the Engineering Institute of Technology, like you said, some people might have been a little, apprehensive about studying online, but the studying that you went through and the course that you went through, especially the master's course, for example, was it a necessary addition to your studies, would you say?
It gave a lot of the background and information, and it gave a lot of the practical skills as well for this project. I think it would be a big ask of me to not have that training and try to implement this type of project. I think there's too many things that can go wrong. It sounds pretty simple, the way we're explaining it, but to actually come from zero to a nice design, it's not that simple. And I think that definitely helped. And doing it as a master's thesis, ensured its success, really. The course and all the different units, they were good. So, and each one of the different units gives some sort of big background, into instrumentation and in piping and alarms and, how things should be alarmed. And I'd probably, the only thing I'd like to add for students coming through, they should get involved as much as they can on the getting hold of the different software that's made available, or that even there's not much you have to purchase. Just get their hands on everything, get drawing. I learnt a lot about AutoCAD drawing and different things like that. So I'd say get hold of the software and play around with it as much as possible, because that was a fair bit of learning for me. So